So we're going to have a look now at how we graph a function. A function is very similar to a regular graph that we're used to with x and y coordinates. We are more familiar with seeing y equals something. Y equals x plus 4. And we have our x and y coordinate. We know a function is when we put an input, so the input could be x, and we get an output. Our output is whatever the function of x was. So whatever we get. In this instance, because we are plotting on an x and y coordinate plane, it's going to be x in and y out. Okay, so we're going to treat this just like we usually would whenever we plot the points. We just need to be familiar with the fact that the f of x is now our y part of the coordinate. So what we're going to do is we are simply going to substitute into here, but we can treat this just as though it says y equals x plus 4. The key part of this is the function. So what we're going to do is every x value, we're going to add 4. So negative 16, negative 12, negative 4, 4, and 8. These are our coordinates. Okay? The first coordinate we're going to go to is negative 20 across, as our x and y is negative 16. So it's going to be here. Then negative 16, negative 12, negative 8, negative 4, which is here, 0, 4, and 4, 8. Now, because we have this function at this point, we don't know if it's a linear graph. We don't know if it is valid between those points. So we can just leave it there. What's interesting about a function is it does not apply to every point. So our function is just going to stop like this. Okay, yes, we track this as a y, but we don't know if this function is continuous or if just the function exists at the values we're given. Okay, so this is our completed function with the points shown. Now, it would be great if you could just pause the video. If you don't want to draw this, you could always screenshot and then try to draw over the top of the graphs. And just try to now have a go at the next two. Pause the video and then come back and I will go through the answers. Okay, so for question 5, we're having a little look now and we're going to treat this. We're going to do 2 minus 2x. So, I always sometimes try to help myself here and try to write in what 2x would be. Okay, so 2x would be 0, 4, 8, 12, and 16. The reason I want to work out 2x is because I have to do two things. Now I just have to do 2, take away the number I have here. So 2 take away 0 is going to give me 2. 2 take away 4 is going to give me minus 2. 2 take away 8 is going to give me minus 6. 2 take away 12 is going to give me minus 10. 2 take away 16 is negative 14. Those are my points. Now I'm simply going to draw them. So 0, 2 up, 2 and negative 2, which is here, 4 and negative 6. And we're hoping to see, because we know it's linear, they should still be in a straight line. We just don't know if it exists in between those points. 6 and 8, and 8 and negative 14. Oh, I think I made a little error there. My mistake. That's going to be 6 and negative 10. 6 and negative 10. And then it's going to be 8 and negative 14. So notice, and my mistake was not reading carefully, that we are plotting these values against our final values. Okay, so there's our 5 points that exist there. If we have a look at question 6, we are going to do negative 2x plus 3. So for the first one, we do negative 2 times negative 2 plus 3. So that gives us 4 plus 3, which is 7. Then we have 5, then we have 3, then we have 1, then we have negative 3, I believe. So negative 2 times 1 is negative 2, plus 3 is 1, and then 3 times negative 2 is negative 6, plus 3, yeah, negative 3. Now I'm going to plot those points. So we're going to go negative 2, 7, so it's going to be here, negative 1 and 5, 0 and 3, 1, 1, and 3, negative 3. So those are our points where our function exists. Okay, I have 2 more. And these 2 questions, we have to kind of come up with the missing points as well. So this is a reverse one where you find some of the inputs and some of the outputs. Have a little go if you want to look back at what we've done. Pause the video and I will go through them in just a moment. Okay, so let's go through this and let's imagine here actually what we always do to our x. The first thing we do is we times it by 2. The next thing we do is kind of minus 4 because these 2 things, 2x would be first and then followed by the minus 4. So if I think about my function as a function machine, I put x in, I times it by 2, and then I actually add negative 4. So if I add negative 4, that's just the same as minusing 4. So this is how I get my output, okay? This will help me because for some of these I'm going to have to go backwards. So for the first one I'm doing x, negative 2 times 2 is just going to give me negative 4. For this one here, I'm going to do, oh, sorry. You can tell I did this in the evening. My apologies. Negative 2 times 2 is negative 4. Then minus the 4 gives me negative 8. Wonderful. So 1 times 2 is going to give me 2. Minus 4 is negative 2. 3 times 2 is 6. Minus 4 is the positive 2. So we have these elements now. Now the reason I have written it like this with a function machine is so that I can say, okay, now my output is minus 4. So when I go backwards, I'm actually going to use my inverse functions. I'm going to add 4 and I'm going to divide by 2. So if I have negative 4, I'm going to add 4, then divide by 2. So that's going to give me 0 divided by 2 is just 0. Same thing for my other one. What if it was negative 6 here? So negative 6 add 4, which is negative 2. Divide by 2 is going to give me negative 1. Now we're going to plot these points. So negative 2, negative 8 is going to be here. Negative 1, negative 6, 0, negative 4, 1, negative 2, and 3, 2. So these are the 5 points that we know that function exists at because we haven't been given any more information. Now, if you haven't had a go at question 8, pause the video. If so, I'm going to go through the answers. This one, if anything, might be a little bit easier because there's less steps to this one. So we know this means times. So we put x in, we times by 5, and we get the output. So if we do these 2 that we have, minus 4 and 2, we're going to get negative 20 and we're going to get 10. Now, if we think about the other ones, we have the output. So if we have negative 25, instead of multiplying, we are going to divide by 5. So it's going to be negative 5. Same thing for the other one. 0 divided by 5 is still 0. 15 divided by 5 is going to be 3. Now we can just plot our points. So we've got negative 5, negative 25, which is here. Negative 4, negative 20, 0, 0, 2, 10, and 3, 15. And these are all the values. Now what's interesting about a function, and I said this earlier, is a function exists at certain points. It's not the same as a graph. You are graphing the function, so sometimes they can be a line, sometimes they can be a curve, sometimes they can just be points. For this information, we don't know if it exists at other points. We aren't told the domain and the range. So this is just an exercise to show you how to plot the points and find the points from our function. I hope it helps.